Hello once again, people. What I've got sitting here on this makeshift bench today is this 2407 WFPB Dell monitor. That's a 24 inch. And in this corner, we've got this U2410F, another Dell monitor, and also 24 inch. Let's flip them over real quick and look at the front side. Now, I know what you're thinking. You're thinking, why is there two good looking monitors sitting here doing nothing? Well, if you squint at just the right aperture, you may be able to notice that this one here does not have an actual LCD panel. This is just the backlight with all its diffusers and stuff, while this one here is complete. It looks like crap, but it's complete. What we've got going on here is that I just picked up this monitor off of somebody on Craigslist, and this monitor I've had sitting around. It had a busted LCD panel, and I removed that because I was thinking about doing something with the backlight, but never really did. And I got this one broken. What I was actually thinking of doing with this monitor is using the main board as sort of a universal LCD board, so I could like test various panels and all that stuff, because the original resolution on both of these is like 1920 by 1200. So I was kind of hoping that I could use the board from that, like I said, as a universal sort of a testing, but I wasn't quite able to get it to work the way I wanted to. So I kind of scrapped that idea and I just kind of kept everything. I thought maybe eventually I'll come across something with a similar panel that could swap into this one, because this one here has a bunch of inputs compared to this one, mostly the addition of HDMI and DisplayPort. Whereas this one does not have HDMI or DisplayPort. It does have an S-Video input, but this one has the regular composite input, so it works just fine. Well, what I want to do is I want to see if I can swap the LCD panel on this one into this one and get this one working. This monitor works just fine, but I would much rather have this one. And if we look at the underside where all the connectors are on these two monitors, we can see on this one here, we've got the DVI, the VGA, the composite, the S-Video, the components, and then we also have a USB port, and that's for the built-in USB hub. It also has a card reader on the side, along with a couple more other USB ports. This monitor, it's got the DisplayPort, the HDMI, DVI, VGA, composite, as well as a component, the audio output there, and we also have the USB ports along with the other USB ports here, and another card reader, except this one here does not have the compact flash, which is not that big of a deal. There is one problem that I think we are going to encounter between these two monitors, and I believe the backlight is a little bit different on both of them as well. They're both CCFL as far as I'm aware, except for the connector interface for this one I think is different than this one, but we'll see. The other problem we'll see when we get to it, but I've already, since this one here was taken apart a long time ago, there's like no screws or anything. It's not even like clipped together at the moment, so this will come apart fairly easily. All right, so that's with the back cover removed, and as you can see, I've got a little baggie with all the screws and the nuts here for the DVI and VGA ports, and here is the cover for the USB and the card reader on the side, and this here should also come off fairly easy because there's no screws holding anything in place. So that cover comes off, and there's our main board and our power supply, and there is the connector that goes to the backlight inverter here, the board. And so this is the board that I was wanting to use as a universal sort of a test board, and I was never able to find any data on the controller that's in here, so that kind of hampered things a little bit. But there's the LVDS connector that goes to the display itself, and as you can see, we have no cable here, and this is what I'm saying, it's probably going to be a slight problem. I do have the cable actually, but I'll show you why I'm saying this is probably going to be a little bit of a problem. I still have to take this one apart, so I gotta unclip it. I'm pretty sure that the front kind of clips similarly to this one, although not quite exactly the same. But I'm going to get that one opened, and then we'll look inside of this one and see what differences there are between the main board and the way to connect to everything and all that. So let me get that done, and we will be right back in a second. Well, I was going to come back when I was done, but it looks like the way this comes off is like you pry around on this bezel around the bottom of around the perimeter of the screen. As you can see, it's just popping out. I don't know if these buttons are going to come off with it or if they are on their own separate board, and actually looks like they are coming off with it. So yeah, that's how that gets removed. All right, that was actually a lot easier than I thought. I just flipped everything over and the back just basically slides off the entire LCD assembly, and the bezel just sort of stays on in the front, and that's the ribbon there that I didn't want to tear. So everything's still intact. Got a bunch of screws to remove to access everything underneath these panels. All right, so I've got the back of this off, and I took off the cover, and on this side here there's a bunch of like thermal pads that are like really stuck onto these heat sinks, and so that made it a little difficult to pry off, but I was kind of gentle, and then eventually it completely peeled off. And I can tell you right off the bat that nope, this is not happening. The interfaces for these T-Con boards are totally not the same, and you can see here that this one has what is it, like a 30 or a 40 pin connector or something like that, and these are the original connectors for this other one. And this is the whole reason why I said this was going to be a bit of an issue, is because I cut this, you know, hoping to be able to interface to this board, and but I cut it in half to just in case. I mean, I could solder all these back together, heat shrink them and all that stuff, and it'll probably work, but as you can see, the pin pitch on these is like way finer than the other one is. I think this one has like 50 pins or something, or 60, I don't remember, but it's a lot more than the other one. So that's one thing. I could, you know, if it was the same, I could have just maybe replaced the T-Con board itself. That's the connector there that goes to the LCD, except that this one is actually not as wide as this one. This one's a lot wider, so that's not going to work either. But one thing I did notice that it's actually going to require a little bit of work on this one is that for some reason the plastic around these twisted pairs is deteriorating, and it's all crispy and it's just like flaking off. You can see all the dust right there. So if I'm going to be using this monitor, I'm going to have to fix this now. Luckily I have a bunch of these connectors like laying around, so I could actually easily fix this or replace it. I'm not sure if I have anything that's exactly the same. That would maybe just require like some repinning or something. This side is totally fine. I'm guessing this side is just all flaking off because of the heat or something. So I got to remove that screw. That'll remove this whole assembly here. And yeah, so this kind of a transplant attempt ended up being an emergency repair. Yay. Here's a close-up of what this wire actually looks like. You can see how it's all brittle and cracked, and it's just flaking off. It's no good, because then obviously we're going to have shorts between the twisted pairs and grounds and all that stuff. Oddly enough, it seems for some reason all these other ones up here were the most affected, but the ones that carry the 5V, like these right here, they are a little bit cracked. You can kind of see the plastic sheathing there, how it's somewhat starting to crack, and there's a little bit more damage right here closer to the connector, but it's not as bad as everything else. And I didn't think it had been affected on the other end, but it actually has. You can see right there how a lot of the sheathing is gone from a bunch of those. So I'm just gonna have to replace all this. So here's my options. This is the original cable. This one that I had in my little miscellaneous connectors bin would have been the perfect replacement if it had been a little bit longer, because the pinout is almost exactly the same. It would require very minimal modification to get it to work. And this connector down here on the bottom, it actually physically fits where this one was, so I really would not have to have done much for this. Or I mean, I could even have like popped these out and stuck them into this connector there, and that would have been fine, but it's too short. It just will not reach, so that one's kind of out of the picture. This one I could have modified, except it's also not long enough. This one's a little too short, so we're gonna have to go with this one here. And it's got the right number of pins, but I'm going to pop these off of this connector here. You just lift up these tabs and then you can pull the connector out, or the actual pin out. And then I'm going to reuse this connector because this one has the locking little tabs here on the side. So I'm going to reuse that the physical connector there and just repin it. And then I'm going to cut these off right here in the bottom and splice them into the ends of here, which I'm going to have to cut these as well because they're not the same type of physical connector. And then I'm going to just heat shrink the ends with this really tiny heat shrink to protect it. I would have liked to have heat shrunk the entire like end of the connector there along with the wire, but the problem is that those pins there, or the female pins, like they fit way too close to the body of the housing, and so it's probably not going to fit in there very comfortably, or I'm not going to be able to get it to fit in there. And just to avoid that, basically I'm just going to like cover up enough just to get it to like the where it's crimped, and that should be fine, just to prevent any shorting going on there. And this whole cracking thing, I mean, this is like the first time I've seen something like this. I've never seen this type of wire crack inside a monitor like that, so most peculiar. And just to make things easier, using the data sheet that I found for that monitor, I basically wrote down here like which pin on this housing goes to what pin on the actual LCD connector, so that way I don't have to be like, okay, this one was here, this one was here, this one was here, this one was here. I can just look at the list here and see which pin went to what kind of interface it was and everything, so that way I can keep everything in check. I can double check it when I'm done, make sure that it's correct, so that it's going to work on the first try. And we always have things work on the first try. Okie dokie. So using this needle and lifting up all the tabs on these two connectors, I've now got these two housings completely boneless. So we'll just kind of keep those there. What I need to do now is, well, I mean, I don't need to, but I kind of would like to reuse this clamp here that holds the cable assembly into the monitor. This here should just separate here by lifting like that. So yeah, that's that. And it's also braided, so it's got some shielding around all these pairs and the grounds and the 5-volt and all that. So let's clip this off. I don't know where little blue is, but this thing here will work. So okay, that comes off, and that should remove. Allow this to come out. Okay, so this should just slide off quite easily, just like that. So this is just a ferrite bead. All right, so here is all the female end of the connectors that go in this housing, and I am going to trim these off a little bit more. I just wanted to give them enough for me to work with, but this should be fairly easy to peel off now that they're all just sort of brittle and falling apart, just like that. So I'll be taking these, and I'll be just kind of twisting them like that. So I'm going to prep all these, and then we will deal with this, because I still have to remove all these from here. So yeah, a lot of tedious little things to do, but it should work once we're done. Of course, things never go quite as smoothly as I hope they will. When I tried to pull the sheathing off of this one, I ended up pulling the entire wire out. So in this case, I think I'm gonna have to like solder the wire into that connector, because trying to undo that crimp is gonna be pretty much impossible. I mean, ideally what I would have wanted to do was to have like a bunch of these connectors that weren't crimped yet, and then have like a crimper that I could basically just snip all these off and just recrimp them, and then that way I have like an entire like cable assembly that I don't have to solder together. I do have this crimper that I bought not too long ago, but this only goes up to like 28 to 24 gauge, and that connector's still a lot bigger than what we have here. So I mean, this wouldn't have worked, but something like this is what I think I would have needed to have. I actually bought that one for some other connectors that I wanted to make, and I don't have the connectors to make those yet, so I just gonna have the tool. But all right, well, so slight change of plans here. Things weren't going quite as well as I was hoping they would on a bunch of these connectors. When I removed the sheathing, a lot of the wires ended up getting pulled out. As you can see on this one here, we only have like 2 strands left, which is really not going to be sturdy enough to support everything. So basically, it's kind of useless. So what I ended up doing instead is what you can see right here on these, and these are all going to be the 5-volt lines going to the display. And as you can see, I have the ends on the wires themselves, and I have no heat shrink. So what did I do? Well, if you look at this one here, or one of these, this is a good one. You can see how the wire is actually kind of crimped in there, but you can also see how I soldered it to right there in that area where the actual wires are crimped on the original connector. So let me show you real quick how I did that. So what I did is I took the little connectors here, and because once the original cable was pulled out, there was enough of a gap in these two sort of like little fingers that kind of like crimp inwards. I was able to take a pick and just stretch them out to make a little bit more of a room there. And after doing that, put it on this helping hands right here, so we have just that end kind of exposed. I took the wire that I want to put on there, and then using this stripper here, using the really smallest one, I was able to remove about maybe about 2 millimeters, or maybe like 1/8 or so of an inch of the sheathing there from the wire. And so I pull that off, make sure it's nice and tight so that it doesn't kind of splay apart. So now we have that. All right, so let's get our soldering iron over here ready. And I have a really small tip there that I've kind of turned into a hook, so I can take this wire. We'll have this help us out here for a sec. So we're going to clamp the wire there and just tin the end. The sheathing tends to shrink a little bit, so that's why I try to not remove too much. But that's tin now. And now what I'm also going to do is take a little bit of flux, just a tiny amount, and I'm going to put it on that crimped area of the wires right here. And I'm also going to scratch a little bit. Scratching this stuff kind of helps remove some of the plating on it, which seems to kind of hinder the solder a little bit. But once I do that, I think it should be fine. I'm gonna clean the tip here again. All right, clean tip. And now I'm going to heat it from below, not where I'm actually going to solder. I want to heat the actual connector itself. And then let's see if we can get this to start flowing on here. Trying to keep this in the shot is really hard when you have the camera on the side. So see if I can do it this way. All right, here we go. And okay, it's melting. We'll just try to get that to flow on there. And kind of get sucked in a little bit. You can see it's still kind of bubbled on the top there. I don't want it to sit there on top. Come on, go in, please. All right, let's see if I can maybe scratch a little bit on there with the soldering iron. And so that should be fine, I think. It just needs, I mean, because the wire itself is really, really thin, so it just needs to have enough solder there to bond to, so I think that's going to be fine. So let's get our wire. I'm going to stick it in through the rear here and just get the, well, first of all, actually, I want to put a little bit of flux on the wire itself. Flux really helps get everything to flow nice and not turn out so chunky or anything. So I'm going to go in from the back, and I'm going to solder the wire itself to the solder on the connector. Okay, there it is. Now you can see that I've got the wire soldered to that little area right there where there is nothing that should interfere with that, so it should be fine. And now, because I have some of the sheathing there in the area where the rear of the connector is going to crimp, I can actually take the crimper that I bought, which I didn't think was going to be useful at all at the moment, and using one of the bigger ones. Yeah, so like I'm going to use this middle section right here, because these are, I don't know if I've mentioned it yet, but they're kind of like two-stepped. So one side crimps the bigger end of the connector, then the other side crimps the smaller end of the connector. So this smaller end of the middle one is actually the one that's been working out fairly well. So I just got to turn it so that the butt end looking thing over here kind of fits that right there. And since the other side is bigger, I don't really risk crushing the other side of the connector. So I'm just going to stick it in like this, and then give it a little squeeze. Once it releases, I now have the end of that fairly nicely crimped. It's fairly mechanically secure there, so that should work just totally fine for what I'm doing here. And so that connector, or this wire, is now ready. Now, it didn't go very smoothly on all of these. Some of them when I tried crimping it, it's because I was actually also using these four as a sort of experimental to make sure that this was actually going to work and see if this was going to be a viable solution to this problem. Some of them it did end up, because I was trying to use the smaller crimp here, it ended up shearing the wire off the end, so I had to resolder it, and because it was already crimped, it was pretty impossible to reopen up. So on some of these, I only have it soldered to the surface right there. As you can see, I don't actually have the sheathing itself like crimped on the connector, but it's fairly secure, so I think it'll be fine. But we're going to do our best to like mechanically secure this to the housing once all of them are done. Okay, so all the soldering and crimping is done, and in case you've noticed here that I have these bundles here labeled as E and these as O, that's because this is the even sets and these are the odd sets. The blue are the grounds and these whites are the 5-volt going to the panel. So because I don't have a assortment of colors like the original cable did, or like this other one does, I needed some way to differentiate what was going to be what. So this way, even though like still like here, you know, I can't readily tell like which cable here goes to what pin on here, at least I know that this like corresponds to, you know, like a certain section over here, and then the other one corresponds to the other section, so I can quickly just kind of omit out. And because I know that the blues are going to be the like the negative side, and then the whites are going to be the positive of the signals, you know, I can more easily quickly tell what's supposed to go like where in the main, in this big housing right here, so it'll make it easier. So the other thing I have to do here is, because it's going to be very difficult to do so after the fact, I need to put the heat shrink on this bundle, and I'm not going to heat shrink it just yet in case I need to change anything. I don't want to make it completely permanent without knowing if it's going to work or not, but I do want to get this on now at least, because if something does need to change, the most likely thing is that I'll have to remove one of the pins from the housing there, but I really don't think I need to do anything like, you know, solder or crimp wise. So that'll just be in there like that for now. And now I'm going to go ahead and pop in all of these wires, or the connectors, into the housing here, and we can go from there. And actually, before I forget, I need to put this thing on too. So all right, let's get all this finished up, get it all popped in here, and then we'll be ready to test it out. All right, so here's a completed cable, and I ran into a couple little problems. First of all, when I crimped the ends of the connectors there, and it's supposed to be kind of roundish like that, but instead, since it flattened it out, made them a little bit wider, so I had a hard time fitting some of these in there. And what I did is I got some pliers, some really small pliers, and I just kind of squeezed them a bit just to kind of make it from like flat to kind of round it out a bit. And that helped quite a bit. The other one was that a few of the wires ended up like breaking off after I had already stuck everything in, of course. Not before, because that would have been too convenient. So anyways, it's completed. I'm not going to finalize all this other stuff until I make sure that it actually works. But it should be properly pinned. I went according to what I wrote down on the little post-it. And one thing I did notice is I kind of screwed up on a few of the, when I wrote it down, but I kind of caught the errors, and I fixed them, so it should be correct. And if everything goes well, it should work on the first try. So we're going to plug it all in, get a power cable, and we'll see if it powers on again, because I mean it used to work just fine. The monitor did work. I just wanted to get this taken care of, since apparently it was an issue. So let's see what happens. All right, cable plugged in, got power. One thing I should probably mention is that if you're working on one of these, they are kind of dangerous, because this is a power supply right here, and it is powered by mains. So there are some high voltages there, as well as on this board, which is the inverter board, which steps up the voltages from here, which is probably, I don't know, 12 or 24 up to a few thousand, just for the cold cathode fluorescent lamps. So don't touch anything there, you know, don't touch anything here, yada yada yada. Be careful. If you hurt yourself, yeah, you're on your own. So all right, that's plugged in, got that plugged in. Let's flip it upside down. Hopefully I'm gonna need transfer that, so I'll do that real fast. Okay, here we go. And the power button's in this corner, so let's hit the power button, and the LED here is on. Let's see if we get the little Dell logo to show up or not. And I think it's cycling through the inputs trying to find something. Or is it? What is going on? Oh, come on. Please don't tell me you're not going to work now. Just my luck. Oh, there it is. So it's showing composite and the colors look correct. So I think, yeah. Must have installed it upside down. No, I'm just kidding. The monitor's upside down. But yeah, it seems to be working. So sweet. That worked on the first try. I told you guys. You guys didn't believe me. Jeez. Yeah, just hitting buttons up here, just trying to get it to show different things. But it looks fine. So yeah, we're good. All right, then. Let's go ahead and finish up the cable. And then we'll just install it permanently. And put this back together. And we're done because, like I said, since we can't put it in that one, it's just gonna have to stay as is. And now, since we want to have some shielding on here where this clamp was gonna go to kind of hold it, what I'm gonna do for that, some of this copper tape stuff that I have around here, and it looks like it's kind of unwound itself a bit, so I'm just gonna wrap this somewhat tightly. Okay, so I was able to go down a little bit further by just kind of running the tape through and then continuing to wrap it back here. So now put this down here. I'm going to put this right here where I started it, just so that the foil doesn't try to come apart or unravel. I'm going to leave a little area exposed for the clamp. Should probably make it a little smaller than that though. Let's make it about there. So it's just going to be like that. All right, let's heat shrink. Okay, so we got that so far. Let's put this clamp in place. And which way did it go? It went like this. Alright, that should be fine right there. And then we're going to do what they did here on this one and put a zip tie just kind of looped around where it provides like some friction for this thing so it's not moving around. Oh man. Got one of the wires here popped off. Man, can't win. Alright, well, I'll fix that. And then we'll go to the next step of the process. Okay, so I fixed that wire. And now, before everything comes apart again, I'm just going to do one more little thing here just to prevent any more wires from trying to pop out. And the wires from this cable are actually a lot more delicate than the original ones were. They seem to be like a lot thicker strands. These are really thin, so they're very delicate. So I'm just gonna mechanically just sort of hold these in place with some of this hot glue, and that should prevent them from trying to break off due to vibrations or anything. Okay, so that should contain things fairly well. I don't anticipate having any issues with it anytime soon, so I'm gonna go ahead and reinstall it. This is what the final assembly looks like. Not too bad, I don't think. And there's the final result. So actually it doesn't even look out of place. Looks pretty good. And I'm going to test it out one more time just before I put the cover back on, because I'm going to have to remove it again just in case something did go wrong when I put this back in. But it feels pretty solid and sturdy, so I think it'll be fine. And yeah, it still looks good. Let's change the input here and see if it'll give us something about the input. There it is. It still looks yellow how it's supposed to, so okay. And I still need to clean the monitor. It's like got a bunch of little spatter on it, like sugary something or other, like you can see it right there. Yeah, it looks pretty gross, so I'll give that a good cleaning first. Yeah, monitor's working fairly well. I mean, nothing unexpected. It's funny, I think it's because of the CCFLs, it almost looks like a CRT here on the display. You can kind of see a little bit of flickering there. But anyways, the whole reason why I kind of wanted to transplant the LCD into the other one is because this monitor here is the same type as the other one that was broken. And because of the mount in the back, this one here, I have it on a 3 monitor stand that's sitting here on the bench now. This one sits a little bit higher than this one does. This one sits a tiny bit lower, so I kind of wanted them both to be like the same height. But then I have another monitor over here that I wanted a vertical, so that, well, I could be looking at like a data sheet on here, because it's much easier to fill up the page like that. You know, I could be doing like something else on this monitor, and then this monitor can have like a schematic or something, or I can be, if I need to, like, you know, check something with like a video output, I can have it hooked up to one of these monitors while I look up whatever information I need on the other ones, instead of having just the one monitor sitting here and having to constantly switch between inputs. And, you know, okay, I need to look this up now, so I have to switch again. Either that or having like a laptop sitting here on the workbench, because that takes up a little bit of room there, you know, and I don't have a whole lot of free real estate here on the bench. So just having this setup here eliminates having a lot of the extra stuff on the bench, or having to do a bunch of tedious like back and forth between inputs. Oh, another thing I did that I haven't mentioned is I actually cut like 5 inches off of the legs on the bench here, so it actually sits a little bit lower than it used to, like from the shelf up here to like the bottom. It used to be a lot narrower, so basically like I could fit the monitor in there and that was about it. But since I cut off 5 inches, now I can fit these monitors up a little higher, and this way I can put like stuff underneath there like you see. So that saves a lot of room as well, and I'm able to have like a lot more stuff like easily accessible. And that way I don't have to keep like going back and forth through containers, like trying to get stuff out, or, you know, like rearranging things and everything. So it just leaves me a lot more room to work on things. So I think it should kind of make things a little bit more efficient. Yeah, this video ended up taking a completely different detour from what I was originally expecting it to be about. Yeah, so I mean, at least the monitor works, and that's really pretty much all I care about. As for this other U2410F, unfortunately it's going to have to continue being broken for the time being, even though the components inside should be fine. But I don't know, I guess leave an F in the comments. Let's pay respects for this monitor for now. I'll just have to put it away. Thanks guys for watching once again. I will see you all around the bench.